Hello friends, my name is Salahuddin. Today I will discuss about the matrix in multiplication. Before going to the problem, I will have a basic discussion about matrix multiplication. Here I have two matrices. In these matrices I have three rows, 1, 2, 3 and two columns. So we can say this matrix as 3-2 matrix. And also I have another matrices. Here I have in this matrices I have 2 rows and 4 columns. So we can say this matrix as 2-4 matrix. After multiplying this matrix with this matrix, we have got this matrix, and in the resulting matrices, in this field the value is 14. We have got this value after multiplying this row with this row, like this way: 1 into 2 plus 3 into 4 equal 14. So to multiply two matrices, we need the number of rows of the first matrices need to be equal with the number of we need to equal the number of columns of the first matrices with the number of rows of the second matrices. And in the resulting matrices, we will get here there are 3 rows and 4 columns. So the resulting matrix is 3-4 matrices, and this is after by multiplying we have got this 3 and this 4, and the number of operations we need here: 3 into 2 into 4 equal 8, 24. We need here 24 multiplication operations. Now we will go to our main problem. Here we have 4 matrices: A, B, C and D. A 2-1 matrices, B 1-3, C 3-2 and D 2-4 matrices. Now our problem is that in which way after multiplying we will get the resulting matrices with a minimum number of operations. Now we will see how the operation varies. If we want to multiply A with B and also with C, then we can multiply it like this way. Either we can multiply first B, A and B, and later we will multiply the resulting matrices with C, or we can multiply C with the resulting matrices with A with resulting matrices with B with C. Now first we will see how many operations we need if we first multiply A with B and later with C. Here A with B, number of operations we need: 2 into 1 into the last index of the B, 3 equal 6. And now we will multiply C with this resulting matrices. The resulting matrices number of rows 2 into number of columns, the resulting matrices 3 into the second matrices number of columns, 2 equal 3, 6, 12. So total number of operations we need here 18. Now we will see how many operations we need here. First we will multiply B with C. The number of operations we need: 1 into 3 into 2 equal 6, and now A for total 2 into 1 into 2 equal 10. So after multiplying A with B with C, we have got the resulting matrices A, B, C. But if we first multiply A with B and the letters with C, then we need 18 multiplication operations. But if we first multiply B with C and then the resulting matrices multiply with A, we need only 10 operations. So the order, so the number of operations vary on the order of multiplication. Now we will solve the problem. We have 4 matrices and we will multiply with each other, and the chain of the matrices is 4 here. We will multiply A, we will find out for A, B, C with D, and here the chain length is 4. We will solve the problem using bottom-up approach of dynamic programming. In bottom-up approach, we will first solve for the minimum length of the chain length when will be L equal 1. When chain length will be 1, we don't need to multiply, we don't need any multiplication. So A with A, the value will be 0, B with B, the value will be 0, C 0, D 0. We don't need any multiplication operations here. When the chain length will be 2, then to multiply A with B, we need 2 into 1 into 3 equal number of 6 operations. For BC, 1 into 3 into 2 equal 6 operations. For CD, 3 into 2 into 4 equal 8, 24 operations. Here we need 24 multiplication operations. Now we will see when the chain length will be 3. When the chain length L will be 3, then we will have ABC and also BCD. Now we will solve for ABC. ABC, we can multiply either A with BC or AB first we will multiply and then later with C. Now we will first solve this. A with BC. We know BC the value is BC the value is 6 and A the value is 0. Now we will find out the multiplication cost. Multiplication cost is A matrix 2, number of rows into number of columns 1 into BC the number of columns 2 equal 4. So the total cost will be total operations need here 0 plus 6 plus 4 equal 10. Now we will see how many operations need if we first multiply A with B and then later with C. Here we know AB the value is 6, for C the value is 0, and the number of multiplication cost here we need for AB the number of rows 2 into AB number of columns here 3 into C the number of columns of single matrices 2 equal 3, 6, 12. So total number of operations here we need, here 6 plus 0 plus 12 equal 18. From this A, B, C, to find out the minimum operations here, we need to take the minimum number of operations. Here, if we first multiply A and B and later we multiply with the resulting matrices C, then we need the number of operations 18. But if we first multiply B with C and then multiply A, then we need only 10. So we will take the minimum number of operations for ABC. ABC, the value we need 10, and we will also keep the order A first, B, C. Okay. Now we will find out for BCD. We can multiply either first B and with CD or first BC with D. Now we will see for this B into CD. Here we know for B the value is 0 and the CD the value is 24, and the multiplication number of operations we need here for B 1 into 3 into CD, the number of columns is 4. So here the total value is 12. So the total number of operations here we need, 0 plus 24 plus 12 equal 36. Now we will see for this how many operations we need for this BC D. For BC we know the value is BC, the value is 6, and for D the value is 0, and the number of operations we need to multiply BC with D. BC, the number of rows here 1, number of columns 2, into number of columns of 7 matrices 4 equal 8. So total number of operations we need here 6 plus 0 plus 8 equal 14. Here the minimum value is 14, then 36. So we will take 14, and the order is B, C, and D. When the chain length will be 4, then we will get A, B, C, and D. And this we can multiply either this way, B, C, D, or first AB, then multiply with the resulting matrices with CD, or we can also do ABC into D. Now we will first see how many operations we need in this way. We know A for 0, BCD for 14, and multiplication number of operations we need here A for 2 into number of columns of A 1 into BCD number of columns is 4 equal 8. So total number of operations here we need 0 plus 14 plus 8 equal 22. Now we will see for this. We know for AB the value is 6 and for CD the value is 24, and the number of operations to multiply we need here for AB the number of rows here 2 into number of columns of AB is 3 into the number of columns of CD 4. So here 3, 4, 12, 24. So total number of operations in this way we need 6 plus 24 plus 24 equal 50, 24, 48, 54. Now we will see how many operations we need in this way. If we first multiply ABC and the later with D. We know for ABC the value is 10 and for D the value is 0, and the total number of operations to multiply we need here for ABC the number of rows is 2 into number of columns of ABC is 2 into number of columns of second matrix is 4 equal 4 to 8, 16. So the total number of operations here we need 10 plus 0 plus 16 equal 26. Here the minimum number of operations is 26, 54, 22. 22 is the minimum number of operations we need here. We have got. And the order to get 22 we have A, B, C and D. And this is our final point, and the total number of operations we need 22 to multiply A with B with C with D. Now we will see in which order we need to multiply it. To get 22 we need to multiply in this order: A, first A, then BCD, and BCD we know we have this order: A with BC and the letter D. So to get the total number of to multiply this A, B, C with D, which the minimum number of operations, we need to first multiply B with C, and then we need to multiply with D, and finally with the resulting matrices we will multiply with A. And in this, after multiplying in this order, we will get the minimum number of operations to get our final matrices A, B, C, D. Now we will see the implementation of the problem. When I equal 1, I less than number of matrices I plus plus. Before implementing, we need an array, suppose P, to store the matrix value 2, 1, 3, 2 and also 4. And we need a table for matrix chain multiplication, suppose for M, to store the value I equal 0. This is for when the chain length will be 1, then we will set value 0, that is AA 0, BB 0, CC 0 and DD 0. Now we will see for more than 1 when the chain length will be more than 1, for L equal 2, L less than number of matrices plus plus. for I equal 1, I less than L plus 1. N minus L plus 1. This is the number of chains we need to find out, and this is for J. I plus L minus 1, and this is the memory table. First we will set the maximum value into max. Now we will find out operations ijk plus I k less than equal j minus 1 k plus plus, and the cost number of operations here we need for I k plus 1 j plus the multiplication cost, that is p I minus 1 zero base index into p with I j k into now if less than j, then we'll set the value operation, and we will return for number of minimum number of operations 1 number of. In this implementation, and in this implementation we need the time complexity here for 3 loops, big O of n cube, and also memory complexity here n square. Thank you for watching the video.